Hi friends, welcome to Basics of Computer. This video will give a clear understanding of converting numbers between decimal and octal systems. We will learn how to convert a given decimal number to a corresponding octal number and back from octal number to decimal. Let us do a quick recap of what we learned in the last session. We first learned about converting a decimal number to a binary. The approach was whatever decimal number was given, we should start dividing by 2 because we are converting to base 2 and write down the quotient and remainder till we reach the last number that cannot be divided and write the answer from bottom to top. That will give us a corresponding binary number. We also learned a mistake that few people do while doing such conversion, that they continue to divide even after reaching the last digit and get the wrong answer, where we should not forget taking the last remainder. We also studied how to convert a given binary number to a decimal, in which case we needed to first write down powers of base 2 because we are converting from binary, like 2 to the power 0 and 1, 2, 3, 4, 5, like that. Whatever binary number is given should be expanded with the place value, and when we solve this, we will get the corresponding decimal number. Let us now first understand basics of octal number system. Octal number system is base 8 system, in which case base B is 8. Going by our rule, the valid digits of this octal number system is B minus 1, that is 8 minus 1. So valid digits in octal number system can be any one between 0, 1, 2, 3, 4, 5, 6, 7. It cannot be 8 or any other number because valid digits are only up to 7. We can also understand the place value of octal number system using base to the power n. First place value is 8 to the power 0. We are taking 8 because we are looking at octal number system, base 8. 8 to the power 0. Second is 8 to the power 1, 8 to the power 2, 8 to the power 3, 4, 5. It continues like this. And if we solve this, actual place value will be 8 to the power 0 is 1. 8 to the power 1 is 8, 8 appearing once. 8 to the power 2 is 8 into 8, which comes to 64. 8 to the power 3 will be 64 into 8, it comes to 512. Similarly, 8 to the power 4, 512 into 8, 8 multiplied 4 times. 512 into 8 will get 4096. 8 to the power 5, 8 multiplied 5 times will give us 32768. So these are the place values in octal number system, going by 8 as a base and powers of 8. If we take a simple number, octal number, suppose 0035 is octal number we have taken. Notice we have written 8 at the bottom here. And if we expand this, take the first digit multiplied by place value. First digit is 5 into place value 1. Second digit is 3. 3 into place value 8. This time place value here is 8. We are taking base 8 system. So next is 0 into 64. 0 into 512. Nothing in front. And if we solve this, 5 into 1 is 5. 8 3s are 24. 0 plus 0. And if we add these numbers, 24 plus 5, we get 29. And this is the corresponding decimal number system. Take a moment to get a basic understanding of the octal number system. Valid digits are 8 minus 1, that is goes up to 7, 0 to 7. Place values are 8 to the power 0, 8 to the power 1, and they go like this. And any given octal number, if we expand using their place value and solve it, we get the corresponding decimal number. Here, we are just understanding the pattern of base 8 number system. Now, we will learn exactly how to convert a given decimal number to octal system. The process of converting a given decimal number to octal system is, say for example, we take 5 to the base 10 and we want to convert this to corresponding octal number system. Take number 5, Start dividing by 8. Why 8? Because we are converting to base 8 system. Can 5 be divided by 8? No. So 8 zeros are 0 and there is a remainder 5. Can we divide anything further? Nothing. We stop here and write the answers in this order 0, 5. So 5 to the base 10 is 0, 5 to the base 8. A very simple example just to get the hang of the system. We'll take one more example. Let's say this time I take 45 to the base 10. Start dividing 45 by 8. 8 5s are 40. We can't go to 8 6 because it will become 48. 8 5s are 40. And because we got 40, there is a remainder 5. Can we divide 5 further? No. Stop here. And write the answer from bottom to top in this order. So 45 to the base 10 is 5 5 to the base 8. We'll take one more example. Take 99 to the base 10. Start dividing 99 by 8. 8 12s are 96. So if we subtract 96 from 99, we get 3. Can we divide 12 further by 8? Yes. So continue to divide. 8 ones are 8 and the remainder is 4. Can we divide this further by 8? No. We'll stop here. So the answer is numbers written in this order 1 4 3. So 99 to the base 10 is 1 4 3 to the base 8. Can you try to solve this problem? Give it a try. Let us see. 482. Start dividing by 8. 8 6 are 48. 2 we cannot divide further. So 8 zeros are 0. So 8 60s are we get 480 and remainder is 2. Can we divide further by 8? Yes. So continue to divide. 8 sevens are 56 is what we will get here. So if we subtract 56 from 60, we get 4. Can we divide 7 further by 8? No, 7 is less than 8. So we stop here. So the answer is 742 to the base 8. So 482 to the base 10 is 742 to the base 8. Did you get the same answer? Cross check. Let us now understand converting numbers from octal to decimal. In this case, we will use the same numbers we used while converting from decimal to octal back from octal to decimal. So that one, we understand how to convert back from octal to decimal. We can also cross-check the answers what we got in the earlier examples. So while converting octal to decimal, the source base is 8. So we'll write the place values first using the pattern base to the power n. First is 8 to the power 0, then 8 to the power 1, 8 to the power 2, 8 to the power 3, 4, 5. So if we solve this, first place value is 8 to the power 0 is 1, then 8, then 64, then 512, 4096, 32768. It goes on. If you remember it by going by the place powers of a base number, that will help us solve the problem easily. We'll take the first example. Number was 005 to the base 8. Now if we expand this, take the first digit 5 into place value 1 plus 0 into place value 8. So this time it is place value 8. Next is 0 into place value 64. Third place value is 64. Nothing in front of that. 5 ones are 5. 0 8s are 0. Plus 0. So if we solve this, we get 5 to the base 10. So 005 to the base 8 is 5 to the base 10. One more example, 055 to the base 8. If we expand this, first digit is 5 into place value 1. Second digit is also 5. This time place value is 8. Second digit is 5, place value 8. Third digit is 0 into place value 64. Nothing. So 5 ones are 5. 5 eights are 40. Next is 40 plus 0. So if we add this 40 plus 5, we get 45 to the base 10. Can you try to solve the next example? Give it a try. Let us see. First digit is 3 into place value 1. Second digit is 4 into place value 8. Third digit is 1. So we got a third digit here. 1 into place value 64. Fourth digit is 0. Nothing there. Into 512 place value. Others we can ignore. So here if you solve this, 3 ones are 3. 8 fours are 32. Second place value when we solve this, it comes to 32. Next is 1 into 64 is 64 plus 0. So if we solve this, 64 plus 32 is 96 plus 3 is 99 to the base 10. So 0143 to the base 8 is 99 to the base 10. Did you get the same answer? Cross check. Let us try to solve one more example. Give it a try. Let us solve. First digit is 2 into place value 1. Second digit is 4 into place value 8. Third digit is 7 into place value 64. Fourth digit is 0. Nothing. So if we solve this, 2 ones are 2. 4 eights are 32. Then 7 64s are, we get 448. 64 sevens are 448. Plus 0. Nothing. So if we add all these three, 448 plus 32 plus 2, we get 482 to the base 10. So 0742 to the base 8 is 482 to the base 10. Did you get the same answer? Cross check. Since we have learned the approach in binary to decimal and decimal to binary, these process start to look simple. So let us do a quick recap of what we learned today. We first looked at how to convert a given decimal number to octal. Given a decimal number, start dividing by 8. Dividing by 8 because we want to convert to octal number system. Till you reach the last digit that cannot be divided. Make sure you have written all the remainders, and once you read the last digit, write the answer from bottom to top. Then we learned how to convert a given octal number back to decimal. Important thing in the process is we should remember the place values following the base to the power n approach, like 8 to the power 0, 8 to the power 1, 2, 3, 4, 5, like that, and have them solved. And when we expand any given number using those place values and solve the answer, we will get the corresponding decimal number. In the next session, we will dive deeper to understand how to convert numbers between decimal and hexadecimal systems. If you like the video, please like and subscribe. Press the bell icon to know when new videos are uploaded, and also share the video among your friends and family. Thank you for watching and have a great day.